A 80 kg person running at 2 meters per second jumped on a 20 kg stationary cart. What's the resulting speed of the combined cart and person? So the person's mass is gonna be 80 kg. And initial velocity is gonna be 20 meters per second. The cart's mass is 20 kg. Now the initial velocity by the person's velocity, and the cart's velocity is gonna be 0. So it is going to be an inelastic collision, so the momentum is gonna be conserved. This is going to be the equation for inelastic collision. So the speed of the combined cart and person gonna be 16 meters per second. A satellite orbits Earth at a height of 2 radius Earths. What's the acceleration due to gravity on this satellite toward Earth in terms of Earth's surface gravity, G? So this is gonna be Earth. This is radius. And this is going to be satellite, and this is the radius to our Earth. We are going to apply this equation. So we are going to be fine. The value based on the surface, because this problem is asking us the surface gravity. So this means the value is gonna be, this is the value of surface. And we are going to apply this to this. So we can find 1/4 gravity. This is what the question is asking to us. The gravitational force of attraction between two masses is 60 Newton. If the distance between the masses quadruple, what is the resulting force of the attraction? So we are going to apply this equation. So this force is gonna be 16 Newton, and we are going to apply this to for radius. So the distance between the masses is quadruple. So we are going to find this. This is gonna be the answer. A 1 kilogram mass is attached to the end at a 1 meter long string. When the apparatus is swung in a vertical circle, the tension in the rope at the very bottom of the circle has a magnitude of 10 Newton. Determine the speed of the mass at the lowest point in the circle. Determine the maximum speed needed at the top of the loop in order to the mass to complete one circle. So the central force is the sum of the forces acting on the mass and is directed toward the center of the circular motion. At the bottom, we can divide equations for finding answers to these two values. So the central force is gonna be force of tension minus force of y direction. This is gonna be this. And in the case of the top, this is gonna be this. Yes, in this case, this force to the y direction is going to be force of gravity, so this is going to be this gravity's value. So we can find the answer is going to be 10 meters per second. Two masses are connected by a string that is wrapped over a pulley. Mass 1 is positioned on a horizontal surface, while mass 2 hangs freely. The masses are released from rest. Determine the acceleration of mass 2. So we can find this. So 7.5 meter per second is gonna be the answer. The meshes connected by string are pulled away a frictionless surface by a 6 Newton force. Determine the tension in the string. We are going to find the total mass. And we are going to find this tension force. So we are going to apply this equation. Then 6 Newton is with this. So the acceleration is going to be 2 meters per second. So we can find tension force by using this equation again. So we are going to do this, apply this weight to this sphere to this mass to this. So we can find 2 Newton. Mass M is positioned 1 meter from the center of a circular disk that is rotating with increasing speed. The coefficient of friction between the mass and the disk is 0.40. What maximum speed can the mass obtain before it slips off the rotating disk? So this is the rotating circular disk, and this is the radius, and we are going to put our object in this. So this is 1 meter. This is the object. So the forces friction is this, and the center force is gonna be equal to the friction force. So we can find 2.0 meter per second. This is gonna be the answer. A 4 kilogram mass is attached to the string and lowered to equilibrium. During the process, the spring stretches 2 meters. Determine the spring constant. So the mass is going to be 4 kilogram and the distance is going to be 2 meters. So this is the spring. So the force of strain is gonna be force of gravity. We can rearrange this equation to this. So we are going to apply these values. So the answer is going to be 220 Newton per meter. This is gonna be the answer. A bar is thrown horizontally at 30 meters per second from the top of a 20-meter tall platform. Determine the horizontal distance traveled by the ball. So the ball is thrown horizontally at 30 meters per second from the top of a 20-meter tall platform. Ball thrown horizontally means the distance, the height is going to be this. We are going to be use this equation for finding height. So we can find the time is going to be this. So we can find 2 seconds. And the motion to the x direction is this, and so we can find 6 meters is the answer. At time is 0 seconds, a force acting in the plus x direction to a 5 kilogram mass that is initially at rest. At time is 2 seconds, a new force is added to the first force. The new force acts in the minus x direction. Determine the acceleration of the object at time is 5 seconds while both forces continues to be applied. Since the two forces have equal magnitude but act in equal but opposite directions, their sum will be 0. Therefore, the acceleration of the object will be 0. The object is moving at a constant velocity. So the answer is going to be 0 Newton.